All right, so we are finishing up benchmark grading period 4 study guide. Again, the standards are 10.0, 11.0, and 12.0. So number 19 is a fraction or a rational expression with polynomials in the numerator and the denominator. So what we're going to do is factor the numerator using our menu. Then we're going to factor the denominator using our menu. Then we're going to try to cancel out any common factors that we can find, and that will be our simplified answer. So here we go. Menu, GCF, special cases. Special cases are PST and dots. Number 3 is if the leading coefficient does not equal 1, we do extra X-man. Number 4, if the leading coefficient does equal 1, we do plain old X-man. And number 5, not all polynomials can be factored. Okay. So, for b squared minus 25, there's no GCF. Special cases, it's not PST because it's not a trinomial. And I believe it's dots because I have 2 terms. We're finding their difference. We're subtracting, and both of these are square numbers. So dots means the difference of 2 squares, which is exactly what this is. So when I factor dots, we use sum and difference. So sum means add and difference means subtract. Now what goes here and here and here and here? Well, the square root of b squared is b, so those are your 2 first terms. Square root of 25 is 5. There's your other 2 terms. You just factored that difference of 2 squares. Look at the denominator. Start back up at the top. Is there a GCF? I do not see one. Is this a PST? It is not, because these are not perfect squares. Is it dots? It's not, because it's not a binomial. Is the leading coefficient something other than 1? No, the leading coefficient is 1. So I'm going to use plain old X-man. So I'm going to go like this. And my A times my C is negative 10, and my B is negative 3. So I know that 10 is 10 times 1 and 2 times 5. The difference of 5 and 2 is 3, so I'm thinking we can make this work. Let's try 2 and 5. If I multiply them, they have to equal negative 10, so one of these has to be negative. Since I'm going to have extra negatives left over, I'm going to make my 5 negative. 2 times negative 5 is negative 10, and 2 combined with negative 5 is negative 3. We have liftoff. I'm going to use these 2 numbers right here in my binomials, and my binomials are b plus 2 and b minus 5. Now I have 2 factors in my numerator. I have 2 factors in my denominator. Factors are things that we multiply together to get a product. Are any of my factors exactly alike? Yes, b minus 5, exactly alike. I'm left with b plus 5 over b plus 2. I cannot cancel out these b's because they're not factors. They're not being multiplied. They're being added. It's completely different. So this is a package deal. Both of these terms are inside a binomial, and this entire binomial is 1 factor. This is 1 factor, and these factors are not exactly alike, so I can't cancel them. So that's your final answer. Look at number 20. Y squared minus 81 over y squared minus 6y minus 27. This is a 2. Okay, in my numerator, I don't have a GCF. Is it a special case? Well, it's not a PST because it doesn't have 3 terms. It's not a trinomial, but this looks like the difference of 2 square numbers to me. These are both square numbers. So the way I factor difference of two squares is sum and difference. So sum and difference. Square root of y squared is y. That goes here and here. Square root of 81 is 9. That goes here and here. We just factored this difference of two squares. Look in your denominator. Is there a GCF? Nope. 3 is a factor of 27 and 6, but there's no 3 in y squared, so no GCF. Is this a perfect square trinomial? 27 is not a square number, so no. Is it dots? No, because it's not two terms, it's 3. The leading coefficient is not 1. The leading coefficient is 1. I mean, it's not... The leading coefficient is 1, so we're going to do regular old X-man. A times C, 1 times negative 27 is negative 27, and B is negative 6. Let's see, 27 is 27 times 1, and 3 times 9, and I think that's it. When I look at 9 and 3, their difference is 6, so I bet we can make those work. So 3 times 9 is 27, but I need it to be negative, so I'm going to make one of these negative. Luke, I'd rather have you watch than stack chairs. Thank you, though. If one of these is going to be negative, well, I'm going to need extra negatives left over, so let's make our bigger number negative. 3 times negative 9 is negative 27, and if I combine 3 positives and 9 negatives, I'm going to have 6 negatives left over. So these are the numbers I'm going to use in my two binomials. So I have a y, and I'm going to have a positive 3 and a negative 9. Okay? Now, factor, 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 factor. Are any of my factors exactly alike? Yep. Y minus 9, y minus 9. So I'm left with y plus 9 over y plus 3. Can't cancel these out because they're not factors. They're part of a binomial factor. This is one factor and this is one factor, and they're not exactly alike, so we're done. Okay, we are on the downhill stretch, baby. Look at number 21. Look at it, even tells us we're back to algebra 10.0, add, subtract, multiply, and divide polynomials. So right here, the first thing you have to ask yourself is, what's the operation? Well, the operation is multiplication. We are multiplying these two polynomials. So when we multiply, I know that this is a binomial, and I know that this is a trinomial. Binomial is 2 terms, trinomial is 3 terms, so that's a 2 by 3. So we're going to do 2 boxes going this way and 3 boxes going this way. So my 2 terms in my binomial are x to the 3rd and 3, and my 3 terms in my trinomial are x to the 5th, negative 2x to the 3rd, and 4. And the reason we do it this way is to make sure that every term gets multiplied by every term. So x to the 3rd times x to the 5th is x times itself 8 times. X to the 3rd times negative 2x to the 3rd is negative 2x to the 6th. And x to the 3rd times 4 is 4x to the 3rd. X to the 5th times 3 is 3x to the 5th. 3 times negative 2x to the 3rd is negative 6x to the 3rd. And 3 times 4 is 12. Now, we've done our multiplication. Now what we have to do is combine all the like terms inside our parentheses. So I like to start with my highest exponent, which is an 8. And I don't see any other x to the 8th. So this guy doesn't have a partner. Nobody to combine with, so we're just going to bring him out here. My next highest exponent is a 6. And this guy doesn't have a partner. X to the 6th wants to hang out with x to the 6th. Don't see any partners. Bring him out.